Alright, in this video, this is the trimmed down version of TEAS live session number 8. This was a live session. I've recorded it, trimmed it down, and this was over in my Facebook group for the TEAS Math. You can find a link to join that in the description below. Now for the first few minutes of the video, I am talking about some updates that I have made. Feel free to skip over that, and there's going to be a timestamp right here on the screen right now where you can just fast forward to that point and start looking at the math problems. But if you're new to this stuff, check out the first part of this video before jumping into the math. Let's go ahead and get started. All right, so welcome folks. It's 9 o'clock Eastern Standard Time, my time. Thanks for tuning in. This is the TEAS Math Live session number 8. I'm not going to spend as much time on what you see right here on the screen as what I did back in session 7. If you look back at live session number 7, I went over a lot of this stuff because there was a lot of new folks, and we have a lot of new folks in this group tonight as well. Nonetheless, some updates for those of you that do have the workbook. I just updated it this past week. You should have got a new email with that download link, as well as the Flexi Quiz. You can find links to both of these in the Facebook groups, on my YouTube videos, etc. But again, I'm not going to go over everything you see here. You can go back and look at section or live session number 7. Speaking of that, over in the group, by the way, the group is still growing at a very nice rate, but something I did just this past week for the new folks, if you're watching this, up at the top of the group, you have this topics tab. Now for this topics tab, what I've done is I've gone back and I've taken every single live session that I have. And if you tap on live session, you can see live session 7. It's out of order, but it's still math. Number 4, number 5, etc. They're all there. You can watch those videos from the live sessions that I did all the way back to whenever my first one was. I forget. Back in October, that was my first one. And this is number 8. So I'm doing these based on the feedback from you all. I love the participation that I'm getting. We haven't even really gotten started yet, and we are at 79 people. I hope that we can get over 100 folks in here. My goal is to help you tackle that math portion of the TEAS. So that's one quick thing there. And something else worth mentioning is when you're in the group, if you want to post a question, by all means do so. Sometimes you may get a quicker response if you use this little search magnifying glass here. Maybe you can type in a keyword to a problem, but you can search for post just like that in the group as well. But enough of that. I said I wasn't going to spend a lot of time on all that stuff tonight. I want to jump straight into 4 math problems with you all, similar to things that I have seen over the past 2 weeks, roughly since the last time that I did a live session based on feedback from a bunch of students, posting their results, giving some tips. With all that said, let's go ahead and jump into the math problems. Here's a preview of what we're doing. Now, I make problems that are similar. I'm definitely not copying things from other books or anything like that, but with math, as a math instructor, it's relatively easy for me to create similar problems, similar topics, and that's what I've done here. We're going to look at a conversion problem tonight. We're going to look at translating a perimeter problem with a rectangle, and we actually have to find the area of this thing. We're also going to look at this is that classic one that I've seen in several TEAS Facebook groups, not just mine, but several of them, where we're dealing with comparing 3 things. And then we'll finish up with what's called the FOIL method. I don't really use the FOIL method, but a lot of you, I'm sure, do use that. And as you can see here, I do have multiple choice for all of these. This is a preview of kind of like what I've done with my mini sessions, 10 students or less. I'm able to talk to those 10 students. We can chat back and forth. I'm not going to pause in between one of these, but I still want to put the multiple choice here. Should you go back and watch this video, you can pause the video and you can go and work it out and see if you get the right answer. So this first question, let's go ahead and dive into it. A newborn baby weighs, already a typo, a newborn baby weighs 8.75 pounds. What is the baby's weight in pounds and ounces? Pounds and ounces. So we already know the baby's going to be 8 pounds and some odd number of ounces. And what I want to hit on here, and I've also hit on this in other live sessions and mini sessions, the 0.75 does not mean 7 ounces. It does not mean 8 ounces. It does not mean 7.5 ounces. This 0.75, you almost want to think about it as being 75% of a pound. 75% of a pound. Now, sure, you don't have to convert it to a percentage, but that's what 8.75 pounds means. Now, why am I emphasizing this? 75%, we can use a decimal, so 0.75 of a pound. But since I want my pound, I want my ounces piece, there are 16 ounces in a pound. So let me write that conversion down. That's one that you may run across on the TEAS test, and I highly doubt they're going to give that to you. We want 75% of 16 ounces. And I don't have my calculator, but just a few tips. We can do 75 and press percent, or just convert your percentage to a decimal. And as a matter of fact, why not do that? We have 0.75 right here. Multiply that by 16 and we get 12. And let me hit on this a little bit more with you. So it's 8 pounds, 12 ounces. Some of y'all might do this. Check this out. Some of y'all might take 8.75 and y'all might multiply it by 16. Some of y'all might use proportions. There's so many ways you can solve this, but something I'm starting to do a lot more now working with students is I'm working on speed, because I want you to get through this test in time. So why would I multiply by 16 here? 8.75 times 16, we get 140. Now, watch this. So this is 140 ounces, by the way. 8.75 pounds is 140 ounces. Well, I'm going to also come and take just the 8 pounds and multiply it by 16 ounces, and that gives me 128 ounces. So what did I just do here? I took I already did this part right here. 8.75 times 16 gives us 140 ounces in all for 8.75 pounds. Now, if I just take the 8 pounds and multiply that by 16, we get 128. If you come and find the difference between these two, you get that remaining 12 ounces that's left over after we already have the 8 pounds. Maybe a crazy way of thinking about it, but it still works. That 12 ounces there, we can find the 0.75 times 16. That gives us the 12 ounces there. But what I want to make sure you're not doing is that you're looking at this and you're like, oh, okay, that's 7 ounces or 8 ounces. And that's not the case. This same concept also applies to time, like 4.5 hours. 4.5 hours is not 4 hours and 5 minutes. It's not 4 hours and 50 minutes. 4.5 hours is 4.5 hours, which is 4 hours and 30 minutes. And that's very common mistakes I see that students make with pounds, with time, things like that. So keep that concept in mind. Now, in my mini sessions that I do with 10 students or less, I give them these problems. I give them a minute and 30 seconds, give or take a little bit. I let them work it out, and then we talk about it just like what I'm doing with you all right now. So I know I'm going through it a little bit quicker. I'm recording this. When you see it on YouTube, slow me down, speed me up. So now switching gears, we're going from what? Doing conversion problems. Maybe some of y'all did a proportion, and now we're switching gears over to geometry. So we got to translate this thing. It says the length of a rectangle is 7 less than 4 times the width. So watch what I'm going to do. The length, I'm going to call that the letter L, is equals, and we got to be careful with this part, 7 less than 4 times the width. Notice I didn't write down anything for the 7 less. I'm going to take 4 times the width, which is 4W, and I want to find 7 less than that. That means we need to subtract 7. Classic translation problem. So the length is 7 less than 4 times the width. Now I'm going to draw a picture. You probably don't have time to draw pictures on the TEAS, but I'm going to draw a picture here for you anyway. So the length is 4W minus 7. And the width, you might say, well, what do I put over here? Well, this is the length. Well, this is also the length. I'm going to go ahead and write 4W minus 7 down here. And it doesn't matter where you put them. You can put them on the outside, inside, no problem. Well, once you've established that, come over here and just stick a W on both of these. These represent the width of the rectangle. So again, we have length across the top. That's a length across the bottom. And since we have that based on the W width, I'm going to come and stick W's for my width. Now, why did I fill all four of these sides in? Well, it says if the perimeter, if the distance around the rectangle is 86 feet, the distance around this rectangle, you have to go all the way around back to where you started. So here's what I'm going to do. I'm going to add up all of these sides, and I'm going to write this down, and it's going to look crazier than what it actually is, assuming you are fairly comfortable with solving equations. So here's my 4W minus 7. I'm going to add this W. Going to add this 4W minus 7. I'm just adding up all my sides, folks. That's an ugly 4, but hopefully we can see that. And then I'm going to add this W to come back to where I started. So 4W minus 7 plus W plus 4W minus 7 plus W. That's the distance all the way around that rectangle. That is the perimeter, and we said the perimeter is 86 feet. So I'm going to set this equal to 86 feet. Don't let this intimidate you too much. Practice your equations. Watch what I'm going to do here. I see a 4W, a understood 1W, a 4W, and another understood 1W. These are all on the same side of the equation. They're all on the left side. Combine like terms. 4W plus 1W is 5W, plus 4 more W's is 9W, plus 1 more, we get 10. And really, folks, all I'm doing there is I'm taking 4 plus 1 plus 4 plus 1, and I'm sticking a W with it. That's combining like terms. Not only that, let's come and do this minus 7 and minus 7. Those are like terms. Negative 7 minus 7 more is negative 14. And then we're going to set this equal to the perimeter. Now we want to solve for W. So solving equations. You need to know how to solve equations on the TEAS test. No way around that. Since I'm subtracting 14 and I want to get W by itself, I'm going to add that 14 on both sides of the equation, both sides of the equal. And the reason I'm doing that, negative 14 plus 14, it gives us 0. They cancel out. Bringing down the 10W, that is all we have left on the left-hand side. And this is equal to 86 plus 14 gives us 100. Let's divide both sides by 10. And W is equal to 10. Because 10 divided by 10 gives us 1, we have 1 W, which is W. And 100 divided by 10 gives us 10. Now, what does this represent? This represents W. W is the width. Now, if the TEAS did say, what is the width of the rectangle? Guess what? You're done. That would be the answer. But that's not what we're trying to find here. It says, what is the area of the rectangle? Well, since we know W is 10, I'm going to take my length and I'm going to plug W into that right there. Or excuse me, plug 10 into that W right there. So we're really taking 4W, that's 4 times 10 minus 7. And if you work all that junk out, 4 times 10 is 40. 40 minus 7 gives me 33. And by the way, these are feet, 33 feet, 10 feet. And now we can find the area of the rectangle. We take length times width, 33 times 10, we get 330 square feet. Just some other things before we move on to number 3. Bear in mind, you might not have to find the area. You might have to find the width. If it says find the width, boom, you're done down here. If it says find the length, it would have been 33. If it said find the dimensions, it would have been 33 by 10 or 10 by 33. Either way, it doesn't matter. But our final answer here is C. But now let's switch gears yet again. Here comes a problem where we are comparing three things. I don't care if it's comparing three different colors of marbles, three different types of trees. In this case, we are comparing vans, cars, and trucks. Now, I have seen some really unique responses to questions similar to this in the Facebook group. Now, I'm going to show you the way that I've been doing it. I've kind of changed the way I've done it since originally making a video on this. And the approach I'm going to take is the approach of using proportions. But something to bear in mind about proportions is proportions only allows us to compare two things at one time. Two things. Let's see what we got here. There's one van for every 6 cars. So I can write 1/6. This is just one way to set this up, y'all. So 1, that represents van. The 6 represents cars. The only thing I can do in this proportion is I can compare cars and vans. I cannot do anything with trucks right now. And lo and behold, here we go. 5 trucks. Not a daggone thing we can do with that in this proportion right here. Just vans and cars. For every 5 trucks, there are 9 cars. Do not come and stick that 9 right there, because this 9 cars is being compared with the 5 trucks. This needs to be an entirely different proportion. So the 5 represents the truck. The 9 represents the car. Now, how is this going to help us? Again, this is one of many ways. Well, look at what it tells us. If there are a total of 90 trucks, our ultimate goal is to figure out how many vans there are. So, 90 trucks. Where can I put that 90 at? Not here, that's vans. Not here, that's cars. Right here. Trucks. You might say, well, how is this going to be beneficial? Hang tight, watch what happens. The only thing we can solve for in this problem is, I'm going to call it C. I can figure out how many cars there are going to be. If I know how many trucks I got, I can use a proportion to figure out how many cars I got. And this is something I've started doing too with the live sessions and the mini sessions. The quickest way to solve a proportion, whatever number is going to be with the variable, the 5 in this case, that is what you're going to always divide by. So with proportions, we cross multiply, we divide, but the number that's with the variable is what we're always going to divide by. So let's cross multiply the 9 and the 90. 9 times 90, that's going to give me a big number. And I'm not going to write that down. We want to work on speed. So we need to immediately come and divide by this number that's with the variable. Let's immediately divide by 5, and we get 162. How is this going to help us? Well, this tells us what C is. C is equal to 162, and you might say, okay, well, that's not even over here. They could possibly put that over there as an answer choice. Oh yeah, I should have done that to kind of fool you, but oh well. So C is the number of cars. I'm going to take that and I'm going to bring it over here, because now I can bring my cars into the picture. So I'm putting my 162 cars at the bottom. And this is going to allow me to solve for V, which is what we need. We need to solve for V in this problem. So same approach, cross multiplying and dividing. Lucky for us, this is a nice cross multiplying. 1 times 162 is 162. And then if we immediately divide by the number with the variable, divide by 6, boom, we get 27. So therefore, the number of vans will be 27 in that parking lot. So here we go. Last one, switching gears yet again. So before I jump into this one, let me write this down. We'll write down 3 plus 5 times 7 minus 2. Now this is not algebra. This is arithmetic. I don't see any variables, so it's just straight up arithmetic. Now, if y'all know how to do this, I already see some answers flying in, great. But for people who don't, I know some of us in this group, maybe even in this live session, we have not taken an algebra class in 10, 15, 20 years. And when you go throwing a variable into everything, it's just like, poof, what in the world's going on? So Let's do arithmetic. If you had to solve this on the TEAS test, I'm hoping you would do parentheses 8, parentheses 5, right? 3 plus 5 is 8, 7 minus 2 is 5. And since we do not see an operator, I don't see an addition, a subtraction, a division, it automatically means multiply. So 8 times 5 gives me 40. Now, unfortunately, folks, you might say, well, where am I going with this? We cannot do that over here. Nope. Unfortunately, we can't. Let's go back to this arithmetic. I'm going to show you a completely different approach, but the magic, this is what's beautiful. One of the many beautiful things about math is we're going to get this same number 40 doing a whacked out looking way. And this is actually going to be the way that we need to apply it to our algebra problem. So here we go. The distributive property. If that sounds remotely familiar, great. What I'm going to do is I'm going to take this 3 and instead of adding it to 5, I'm going to distribute it to this 7. And every time I distribute, I'm going to multiply. 3 times 7, that gives me 21. I'm going to distribute this 3 to the other term. How many ever terms are over here? I'm just going to keep on distributing. Got to watch our signs. 3 times negative 2 is negative 6, so I'm going to write subtract 6. This is the distributive property in a crazy form, but this is how it works. Now let's repeat the process for this 5. Positive 5 times positive 7, positive 35. And then one more time to finish this off, positive 5 times a negative 2, that's negative 10. Now, all these arrows that I'm drawing, I'm not trying to confuse you, but folks, if we take this, let me go grab that calculator. I'm just going to go from left to right. Addition and subtraction, left to right, just like we read. So I'm going to take my 21 minus my 6 plus my 35, and then I'm going to subtract 10. And if I did my math right, boom, check it out. We get the same answer. This is not coincidental. This is just the way it works. So let's take this concept and let's finish up this last problem for tonight. And I'm going to make that a little bit bigger. All right, so here we go. Taking the 3x times x, something you need to go ahead and tell yourself. Anytime you multiply x by another x, long story short, it's going to be x squared, and it really revolves around doing something called adding these exponents. But 3x times x, we do get a x squared, but don't forget this either. This is a 3 times a understood 1. So 3 times 1 gives me 3. Therefore, 3x times x is 3x squared. And I do remember the FOIL method. Yes, I do see that. First, outer, inner, last. That's right. I like it, but if you were to search my YouTube channel for multiplying polynomials, sometimes you may have a polynomial with 3 terms instead of 2, and the FOIL method falls out the window. But the FOIL method does work when you have 2 terms times 2 terms. Just keep that in mind. I do see the FOIL method popping up over in the chat. But anyway, let's keep on going. So I have this 3x again, and I'm going to distribute it over here to this positive 5. So 3x times 5, well, 3 times 5 gives me 15. We can't forget about this x. It's not going to be x squared. We don't have any more x's to multiply by, but we still can't forget about that one. Now let's move on to the minus 4. Negative 4 times 1x, well, negative 4 times 1 is minus 4. Don't forget about this lonely x over here. And then last but not least, negative 4 times a positive 5. A negative times a positive is always a negative. Therefore, we get minus 20. We are done multiplying. Now it's all about combining like terms. And what I see people do here is they want to keep adding exponents. And I emphasize this, combine like terms. When you combine like terms, all you're doing is changing the numbers in front of the variables. You're just combining things that are alike. For example, here, if I look at the 3x squared, I don't see any more x squareds in this problem, so I'm just going to drop it on down. I do see two like terms right here in the middle. 15x minus 4x. They're like terms because they both have an x. And literally all you're doing here is 15 minus 4. 15 minus 4 gives us a positive 11. Just don't forget your x. And then there are no more terms other than this negative 20. So bring down your minus 20. And this matches choice, and I see it. I see D's down the chat board. Fantastic. All right, Miss Witherspoon, Shanita Witherspoon, congratulations. Free multiple choice math quiz that currently has 115 questions. And then you get a free copy of my math book as well. So I will be in touch with you. And folks, again, thank you all so much for attending TEAS live session number 8. Have a great weekend. Thanks for these comments right here at the end. I wish I could have taught y'all too. I wish I could have y'all in a face-to-face classroom. It would be a blast. But enjoy your weekend, folks. I'll talk to you soon. Good night.